All right, it's 2 o'clock, so I think we're going to get started. Welcome to the Now Micro Tech Connect. Today's Tech Connect session is going to be on remote management with Always On VPN. My name is John Anderson. I'm a senior systems consultant here at Now Micro. I primarily work on device and identity management, and I work a lot with the Microsoft Endpoint Manager suite of tools. Lately, though, I've been working a lot on remote device management, specifically with Always On VPN. You can find me on Twitter at ConfigJohn, and I also keep a blog. As I mentioned, I work for Now Micro. We're based in St. Paul, Minnesota, and what we do is can be described as a device lifecycle company. We can help with purchasing, customizing, and deploying devices. Then we have resources like myself or my colleagues that can assist with management of devices. We also have our DICE asset management tool. And finally, we can help with decommissioning and recycling old devices. So if any of that sounds interesting, feel free to check us out. I also quickly wanted to highlight our newly updated DICE asset management tool. This tool has undergone a lot of changes recently and can be very helpful with monitoring your whole device fleet, but specifically devices that have maybe recently gone remote. Some of the higher tiers of the product include live data collection from devices through our DICE agent, and can even do things like geolocation or remote management of devices. So if that sounds interesting, feel free to check that out at nowmicro.com/dice. And finally, before we get into the meat of the presentation, I just wanted to remind people to get involved or stay involved with the tech community. Can really help with learning new technology like Always On VPN or keeping up with existing technology. In particular, I found Twitter to be helpful. Like it says there, make your bathroom visits productive. So jumping into it, the first question we should ask is, what exactly is Always On VPN? So Always On VPN is Microsoft's solution for providing Windows 10 computers with remote access to resources in an on-prem enterprise network, which basically means it's a VPN. It's used to provide clients with access to resources that they can't get in the cloud or at home. But the main difference between this technology and a traditional VPN is that it connects automatically and is transparent to the end user. A common problem I see is organizations that have a traditional VPN deployed, but it requires user interaction to connect it. Some users don't ever connect the VPN, which means their devices don't get connected and then aren't managed. So if that's an issue that you've experienced, maybe Always On VPN can be a solution. Always On VPN was first introduced with Windows 10 1607, and it is a Windows 10 exclusive technology. It won't work with earlier releases of Windows 10, so like 1511 or 1507. Not that anyone should be on those anymore anyways. And it also won't work with older releases of Windows like Windows 8.1 or Windows 7. Microsoft has positioned Always On VPN as the successor to Direct Access. So if you're not familiar, Direct Access is another Microsoft remote access technology that was released back with Server 2008 or 2008 R2, I believe. And both technologies provide the same automatic and seamless connection and are pretty close to having feature parity. However, there are still some differences between the two, and we'll take a quick look at those. So if you've been looking at both of these solutions, like I said, they have the same type of features, but Always On VPN seems to be more of the technology of the future. Just a quick look at a couple of differences. Both devices support on-prem AD-joined devices. However, Direct Access only works with your on-prem AD-joined devices, whereas Always On VPN can be configured to work with Workgroup or Azure AD-joined devices. Always On VPN integrates with newer technologies like Windows Update for Business, which can provide multi-factor authentication. Direct Access is an IPv6 only technology. The connection happens using IPv6, and then IPv4 translation technologies are used to connect back. Always On VPN can work with IPv4 or IPv6. Direct Access is a fully Microsoft technology, so it requires Microsoft clients and Microsoft servers on the back end to implement it. Always On VPN does require Windows 10 for the VPN client. However, the backend infrastructure does not have to run on Windows Server. It is possible to use third-party VPN software or appliances. And then, as I mentioned before, Always On VPN does not support older Windows OSs. So if you still need to support Windows 8.1 or Windows 7 in your remote access solution, then direct access would be the Microsoft solution to use. And then finally, the last item there is just about a certificate authority or a PKI that's required. Direct access can be configured to operate without needing certificates. However, Always On VPN does require certificates to be used for authentication. So both technologies are still valid to implement. I haven't seen Microsoft say anything about direct access being end of life. I think they're just focusing their development on Always On VPN going forward. But if direct access seems like a better fit for your organization, you can still look to deploy that as well. So jumping into Always On VPN, how does Always On VPN work? Well, it uses a lot of familiar VPN technology. So if you're familiar with deploying a traditional VPN using Windows solutions, a lot of this should be pretty easy to pick up. Firstly, we have familiar VPN server technology. In the presentation today, we'll be looking at a VPN server running Windows Server 2019 and the routing and remote access server role. Again, it is possible to use a third-party VPN appliance too. Secondly, we have familiar VPN protocols. So IKEv2 and SSTP are two of the more commonly used protocols with Always On VPN and are just solid VPN protocols in general. Third, we have familiar VPN clients. The built-in Windows 10 VPN can be used, which gets rid of the need for applying or deploying additional VPN software, but third-party software can also be used on the client side. The new piece of the puzzle is the configuration of the VPN client. So Windows 10 introduced new VPN settings. These settings are configured using the VPN v2 CSP, or Configuration Service Provider. If you're not familiar with what a CSP is, it's an interface that can be used to configure settings on Windows 10. It's similar to traditional group policy, except that it allows the settings to be configured through Intune or other MDM solutions. On the back end, whether the settings are being set through group policy or a CSP, it's doing the same type of thing, modifying registry keys or updating configuration files. So what are some of the prerequisites for a basic deployment of Always On VPN? Well, we need at least one VPN server for clients to connect to. Again, in my example, I'll be using Windows Server 2019. We'll also need at least one Radius server to perform authentication. Again, in my example, I'll be using Windows Server 2019. We'll need a certificate authority or PKI to issue certificates to our users' computers and servers. And finally, we'll need Windows 10 clients. For user tunnels, we can use any version of Windows 10 that's 1607 or newer. And it's not edition limited, so we don't have to use Enterprise or Education. We could use like the Pro Edition, for example. But for device tunnels, Windows 10 1709 or newer is required. And that is specifically limited to only the Education or Enterprise editions. So I've just been talking about user and device tunnels. Let's talk about what those terms mean in the context of an Always On VPN deployment. So Always On VPN has two different types of VPN tunnels that can be connected. The first type of tunnel is a user tunnel. This type of tunnel is not connected until a user who has Always On VPN configured logs into a computer. When the computer does log into the computer, the tunnel is automatically connected in the background. This type of tunnel, like I said, works with any version of Windows 1607 or newer, and it's great for granting users access to resources that they need. So file shares, applications, maybe remote desktop connection to their computer at work. The second type of tunnel is a device tunnel. So this type of tunnel is automatically connected as soon as a device is powered on and obtains an internet connection. So you can have a computer that comes up to the logon screen, and as long as it has an internet connection, the device tunnel will connect in the background without a user having logged in. This type of tunnel is usually used for providing access to like more management type infrastructure, so things like Active Directory, group policy, and management tools like Configuration Manager. The functionality of this tunnel makes it great for providing things like a first-time logon experience. For example, say you have a remote user who needs a new device or a device refresh. You could get the new device shipped to your corporate headquarters, image it up on site, and then configure the Always On VPN device tunnel. Then you ship the device out to the user. They receive the device, power it on, and get it connected to their network. And the device tunnel connects in the background, giving the device access to Active Directory, and the user can perform that first-time user logon right from home. So definitely cool technology there. A couple other notes about the device tunnel. As I mentioned before, it requires Windows 10 1709 or newer. Also only works with the IKE v2 VPN protocol. So I mentioned multiple protocols could be used, but this one specifically, device tunnel only works with the one. And while just looking at these bullet points, it may sound tempting to just deploy the device tunnel and ignore the user tunnel. Keep in mind that the device tunnel has less strict authentication requirements and feature availability when compared to the user tunnel. I've linked a good blog post by Microsoft MVP Richard Hicks that does a good job of talking about when and where the device tunnel should be used, so definitely check that out. And everyone will get a copy of this slide deck afterwards too. I do have a lot of links throughout here. Finally, both of these tunnels can be configured in either split tunnel or forced tunnel configuration. So a split tunnel VPN is one where only traffic destined for the corporate network is sent through the VPN connection. For example, a user tries to access an on-prem file share, that traffic goes through the VPN, but then that same user goes to stream Netflix, that traffic goes out through their local internet connection. Forced tunnel configuration sends all traffic through the VPN, which could be quite bandwidth intensive. So I would generally recommend using split tunnel in most scenarios and really only use forced tunnel if you need to. So let's take a quick look then at how the VPN tunnels actually connect. So this graphic shows the VPN connection process for a user tunnel in a basic Always On VPN deployment. In this scenario, the VPN server is located in a perimeter network and has two network adapters. So first step, the VPN client sends a connection request out to the external host name or IP of the VPN server, which hits your perimeter or edge firewall. That firewall passes the connection request through to the VPN server. The VPN server passes the connection request along to the Radius server on your internal network. That Radius server communicates with Active Directory and the certificate authority to validate the connection request. And then the Radius server returns either an accept or deny response to the VPN server. And based on that response, the VPN server either allows or denies the connection. And then let's look at the same thing for the device tunnel. You can see here that the device tunnel connection process is simplified when compared to the user tunnel. The device tunnel does not use the Radius server for authentication. Instead, the VPN server directly performs the authentication. So again, the first step, the VPN client reaches out to the external host name. The edge firewall passes that connection request to the VPN server. And then the VPN server validates that the computer authentication certificate matches the root certification authority configured on the VPN server and either allows or denies the connection request. All right, so now that we've seen the connection process, let's take a look at the certificates that are required to make the authentication work. The first certificate that's needed is the one for the VPN server itself. So if we're using IKE v2 for our VPN protocol, the VPN needs to have a certificate installed that has the IP security IKE intermediate extension. If you're using Active Directory certificate services to deploy the certs, make a duplicate of the RAS and IAS server template, and that'll get you where you need to go. If you're using SSTP for the VPN protocol, the VPN server needs to have an SSL certificate installed. And the CRL, or certificate revocation list, for this certificate must be externally available. So if the certificate if it's being issued by like an internal PKI, then your internal PKI needs to have its CRL published on the internet, which usually isn't the case. So for this certificate, I'd recommend just using a certificate from a third-party CA. And if you have an existing wildcard cert, that can be used here too. And then for both of these certificates, the subject name and subject alternative name should include the external host name of the VPN server. I've included a link to the Microsoft documentation on this slide that walks through the steps to create these certificates. The Radius server also needs a certificate, but this is much more simple than the VPN server. Again, if you're using Active Directory certificate services, just make a duplicate of the RAS and IAS server template and deploy it to the server. And I've included another link to the Microsoft documentation there. So in addition to the server certificates, client certificates are also required. If we're using the user tunnel, user certificates will need to be deployed. The user certificate must have the user authentication property. And as a side note, if your user accounts don't have the email field populated on their AD objects, don't include email name in the subject name. Otherwise, you'll get a bunch of warnings when the certs are enrolled. If you're using the device tunnel, computer certificates are required. The computer authentication certificate needs to have the computer authentication property or client authentication property. If you already have an existing computer authentication cert that you're using for another solution, like wireless authentication or configuration manager client authentication, you could reuse those certificates to work for the Always On VPN device tunnel authentication as well. So you don't necessarily need to create a new computer certificate. As I mentioned earlier, Always On VPN allows for multiple VPN protocols to be used for the user tunnel connection. IKE v2 is a good choice for the VPN tunnel. It's fast, secure, and it has a good ability to reconnect quickly after connection interruptions. This VPN protocol does use UDP port 500 and UDP port 4500 for communication. This can cause the tunnel to fail to connect on certain networks if these ports happen to be blocked. So maybe a random hotel or some other company that you're visiting has these ports blocked, the VPN tunnel wouldn't be able to connect back through. So that's one thing to keep in mind with this protocol. This is also, again, required for device tunnels. It's the only protocol that will work for the device tunnel. SSTP is another good VPN protocol. It's fast and secure. The connection's encrypted using SSL. The benefit of SSTP is that the traffic uses TCP port 443. This means the connection is very firewall friendly. So really it should be able to connect from anywhere that the device can get an internet connection. I think you'd rarely, if ever, see 443 being blocked. And then there's L2TP and PPTP also as supported VPN protocols. However, both of these are older, slower, and less secure options. I generally recommend using IKE v2 or SSTP instead. And as for both of those protocols, they can be used together as well. So you could deploy a device tunnel that uses IKE v2 and a user tunnel to the same machine that uses SSTP. So they're not, you don't have to use all one or the other. So now that we've gone through the certificates, let's take a look at the configuration or some configuration options for the VPN server. So one of the first things to consider is where to place the VPN server on your network. A common recommendation is to place it in a perimeter or a DMZ network. Generally, this provides better security as the connections from the internet won't be terminating on your internal network. However, there's going to be more network configuration required, as you're going to have to make sure firewall ports are open between the perimeter network and your internal network so that communication can happen successfully. The VPN server can be placed on your internal network as well. This is potentially a less secure option. However, it can make for an easier network configuration. Another option could be to utilize VLANs or access control lists to control, communications going to the VPN server. There's really a lot of different options here, and this is a pretty important part of an Always On VPN deployment. So definitely spend some time discussing this before starting a project. Another thing to consider is how many network adapters you have on the VPN server. So again, a common recommendation from like Microsoft is going to be to have your VPN server in a perimeter network and have 2 network adapters configured. One that communicates with the edge firewall and the internet, and then one that communicates with your internal firewall. However, having the VPN server configured with only 1 network adapter is also a valid configuration. If you do use 2 network adapters, there's a few things to keep in mind. The IP and gateway should both be set on the external adapter, and then an internal IP and DNS should be set on the internal adapter, and then you would use static routes to provide access to internal networks. We'll take a look at this in the demo in a little bit. So then the next piece is the radius server configuration. So the radius server, pretty straightforward for the network placement. Generally, it's going to be on the internal network. It needs to have access to your Active Directory and your certificate authority. and then some firewall ports for communication. So the radius server and VPN server need to be able to communicate over UDP 1812 and UDP 1813. So if there is any firewalls in between them, including the Windows firewall, those ports need to be open. There is also legacy ports, 1645 and 1646, that may be used, but usually shouldn't be. So then the next piece is the client configuration. So as I mentioned, this is kind of the new piece that makes the whole Always On VPN technology tick. And the VPN profiles are configured using that VPN v2 configuration service provider. There's multiple options to configure the settings in the VPN v2 CSP. You can configure the settings directly using Intune, or you can create an XML file that contains the settings and deploy that through Intune, or deploy it directly using PowerShell. And we will end up with separate XML files for user and device tunnels. So if you deploy both tunnels, you'd have at least 2 different XML configuration files. For a full list of settings, see again this link. If you just Google search VPN v2 CSP, it should be like the first result. There's a Microsoft Docs page that just kind of gives you all of the available settings. A couple other points about the tunnels. The user tunnel, before we can deploy that, we need to manually create it and connect it at least once to get some specific authentication data, which I'll show an example of that in our demo as well. The device tunnel, when we're working with that, it must be installed under the context of the local system account. So if you're deploying it through like Configuration Manager or Intune, it'll automatically take care of that. Otherwise, if you're doing it locally, we need to use a tool like psexec or something to get a local system command prompt. All right, so now that we've spent some time talking about the basics of Always On VPN, let's look at a demo of a simple Always On VPN deployment. It's going to be a live demo, so hopefully things go to plan, but you never know. Close out here. Okay, so the first thing that we'll look at is certificates. The servers and clients both need certificates. So I've just connected to my lab environment here, and I'm looking at my certificate authority. I'm using a Active Directory integrated certificate authority. So if we look at, I've got a server template here that I made for the Always On VPN, VPN server authentication. The main thing to keep in mind on here is on the extensions tab on application policies. We need to make sure again that we have this IP security IKE intermediate extension. And then on the subject name tab, we want to say supply in the request, since this certificate is not going to be under the name of the actual name of the VPN server. It's going to be the name that we choose to be our external host name. So like aovpn.nowmicro.com or something like that. And then under the security tab, I've set this up to be able to be enrolled by any servers that are a member of this Active Directory group, AOVPN VPN servers. And it's a good idea to go through and create Active Directory groups just for your VPN servers, your network policy servers, and your users. That way, when you're creating these certificates, you can kind of better target them at the resources that are going to actually need to enroll them. And this certificate, again, cannot be auto-enrolled since we need to specify information in the request. The network policy server cert is pretty basic. Really, it's just a copy of the RAS and IAS template in here. So straightforward on that one. The user authentication has a little bit of, or a couple of notes to take a look at in here. So on the cryptography tab, we need to make sure we have key storage provider selected. And then in the providers here, we're using Microsoft Platform Crypto Provider and Microsoft Software Key Storage Provider. And then again, on the security tab, make sure that we have this targeted at our AOVPN users Active Directory group. And we can set this certificate to auto-enroll. And what we'll do is create a group policy that tells users to auto-enroll certificates, and the certificate should just be automatically installed for any users that we put in the group. And then the other thing I made a note of here too was these email name checkboxes. So by default, I think both of these are checked. If you don't have the email property filled out on your Active Directory user accounts, uncheck both of these. Otherwise, you'll get a bunch of warnings and errors. And then the computer authentication certificate. So that, again, is basically just a duplicate of the computer cert in here. So really nothing special there. If you have an existing cert that you used for some other solution, you could reuse it for the Always On VPN deployment. And then the other cert I don't have in here is the SSTP certificate. Again, if I was going to be using SSTP, I would not issue the certificate from here. I would just go get a SSL certificate from a third-party CA or use our wildcard certificate. All right, so then let's go connect into our VPN server. So we created our VPN server certificate. What we want to do is get that enrolled on here. So I've opened up the MMC snap-in and connected to the local computer certificates. Make sure you're looking at local computer and not current user. Then you can right-click on personal, go to all tasks and say request new certificate. This will open up the certificate enrollment wizard. We want to enroll from Active Directory. And there's our AOVPN VPN server cert. We have to click on the link to supply the subject name information. So the subject name should be common name, and that's going to be AOVPN. I'd put in my external host name and add that. And then the alternative name is going to be DNS. And go ahead and add that in there. Then we can click OK and enroll that certificate. So now in our certificates here, we've got our AOVPN external hostname certificate. The next thing to look at on the VPN server is the network adapter configuration. So in this example, I've got a server with two network adapters, an external adapter and an internal adapter. The external adapter, generally you want to uncheck any of these protocols that you're not using, just so that there's less surface exposed out to the internet. IPv4 connection, you should specify whatever your external IP address is and your gateway to get out to the internet, but leave the DNS servers blank. And then on the internal connection, you would want to specify an internal IP address as well as a subnet mask, and specify your internal DNS servers, but leave the default gateway blank, because the default gateway has already been specified on the external adapter. So then the question is, how do we get traffic routed through to the internal network? We've got the DNS servers, but no gateway. So the answer there is to use static routes in the VPN server. So if you come into PowerShell here, we can use the new-net route command to create static routes for our various internal interfaces. So say our internal network is, the 10./8 network. We can say new net route, address family to IPv4. Our destination prefix is 10.0.0.0.8. Our interface alias, or where we want to apply this to, is our internal adapter. And then the next hop is the gateway that's going to get my connection through to the network internally. And then multiple different routes could be created for multiple different networks that might exist. If you want to see what currently exists on the machine, you can do a get net route, and it'll show back a list of the currently configured routes. So now we've got the certificate installed, and we've got our networking taken care of. Well, at least in Windows, there'd still be network firewalls and stuff to take care of. But the next piece on here is going to be installing the remote access role itself. I've already installed that just to save time. You can install it through PowerShell or just do the add roles and features. But once the remote access role installs, you'll get this notification up here. If you click on that, you can say open the getting started wizard. And then we want to deploy. So direct access and VPN are still kind of tied together, but we want to just deploy VPN only. And that opens up the routing and remote access console. So we can right click on the server here and say configure and enable routing and remote access. We'll go next. We want to do a custom configuration, and we want to provide VPN access. Pretty basic. And just telling us to make sure that Windows firewall ports are open. Go ahead and start the service. And give it a minute. There we go. So now the service is running. We need to make a few configurations. So if we click on the server again and go to Properties, and then on the Security tab, we don't want to use Windows authentication. We want to use Radius authentication. So select Radius and go to Configure. Then we want to add a new Radius server, and that's going to be and then we come up with a shared secret for your NPS server. This should be something much longer than what I'm typing in. And then you can optionally change the port and the timeout and any of that if you want to. So then now the VPN server will forward our authentication request through to this Radius server. We can also set up the Radius server for doing accounting or logging. I'm not going to do that right now, but you can set that up as well. Then under the IPv4 tab here, we need to control how our device is going to get IP addresses. So it can be done through DHCP or as a static address pool. The DHCP option acts kind of weird. It like hands out IPs from whatever network is configured on the adapter that's being used. So down at the bottom here, you can select which adapter to use. So you'd say internal. So if you have a 10 dot address specified on that adapter, DHCP addresses would be handed out in that same range. Usually what I do is just specify a static address pool. So make sure that my DHCP server is not handing out whatever addresses they are, and then just specify, you know, a range of addresses. So something like that, and you can see the number of addresses that you're going to get out of the range. And then down at the bottom, if you're having two adapters, make sure you select your internal adapter as the one to obtain DHCP addresses from. Then we can click OK there. And it's thinking about it. Probably should have just hit cancel. There we go. Okay. So then the other thing we want to do is go click on ports and do properties. And we see all these different VPN protocols in here. What we want to do is disable any of these that we're not going to be using. So like PPTP, for example, we don't want to allow remote access connections there. L2TP, not allowing connections there. In my example, I'm also not using SSTP, so I'm going to disable that one. So then IKEV2 is our only remote access protocol left enabled. We just want to make sure that our number of ports are bumped up to, you know, however many connections we think we might have at one time. And then you can click OK there. And then really at this point, that's kind of all the configuration we need to do in the GUI interface on here. There is still some other things that can be done, though more of them are done through PowerShell scripts. So like if we're going to use a device tunnel, there's a PowerShell script we need to run to enable computer certificate authentication. Or maybe if we're using IKEV2, we want to enable support for IKEV2 fragmentation, or maybe increase the security of the IKEV2 connection. I'm not going to do those right now, but in the PowerPoint slide deck, I have included links to blog posts and those scripts where you can find them online and run them yourself if you need to. So the next thing to look at then is the Radius server, or network policy server. So again, this one is just going to be a Windows server. You would install the network policy server role through just add roles and features. I've already done that here. So once it's installed, just open up the network policy server console. And then the first thing that we want to do is right click on NPS up at the top and say register server in Active Directory, and just hit OK there. It'll reach out and register this as a network policy server in your Active Directory. Then we go down here to Radius clients and say add a new Radius client. And we put in the name of our VPN server, select whichever address is the internal IP address, and then type in that same shared secret that we typed in before. Oh, friendly name for the client as well. All right, so now we've got a Radius client. So I'll go back up to the network policy server at the top here, and we say we want to configure VPN. And we're configuring a virtual private network connection. So we go next. We can select our newly created Radius client. And then we want to uncheck the MS Chat v2 authentication protocol and check the extensible authentication protocol. And we want to select Microsoft Protected EAP here, and then hit configure. I should install the network policy certificate first, shouldn't I? So real quick, in the again in the local computer certificates on the network policy server, I'm just going to install that Active Directory certificate that we had deployed out. There, magic now lets me in. So I want to remove MS Chat v2 from down here at the bottom, and then add smart card or other certificate. And if it seems like all these steps are hard to keep track of, if you're trying to keep notes, Microsoft does document all of these steps. And in the PowerPoint slide deck, I have included links to the Microsoft documentation where you can follow through all of these step by step. So go next here. Here's where we want to specify our groups. So what users are allowed to connect or are allowed to authenticate this connection. So this is where we would specify our AOVPN users group. So only users that are a member of this group are going to be allowed to establish a Always On VPN user tunnel. We're not going to do anything with IP filters for right now. Encryption settings are default, nothing at realm name, and then we go ahead and click finish. And at this point, the network policy server is, again, pretty much set up. Really, there's not a whole lot to a basic deployment of Always On VPN on the server side. Yeah, really, that's it there. So then the next piece is going to be looking at the client configuration. And before I actually jump into that too, I just did show configuring the server side with Windows servers. But like I said, again, too, it is possible to do the configuration with other third-party VPN solutions as well. So the client configuration, as I mentioned before, we can use XML documents to contain all of the different VPN v2 settings, and then use PowerShell to apply these XML files to machines to set up the VPN profiles. So I just want to take a quick look at a basic XML file for a device and a user tunnel. So in this one, this is a XML file for a device tunnel. Just kind of going through the settings here at the top, we have always on is set to true. That means that the connection is going to automatically try to connect. Device tunnel is set to true since this is a device tunnel connection. DNS suffix, so here's where you could specify like a comma separated list of DNS search suffixes that you want to use with your VPN connection. Register DNS is set to true. We want to register the DNS for the device tunnel so that we can, say like remote connect to the device through Configuration Manager. Trusted network detection, this one is an important one. This is how does the tunnel determine when it should try to connect? So here you can specify, again, a comma separated list of trusted networks. And if the client detects that it's on one of those networks, it won't try to connect to your VPN. But if you take it somewhere else, like to your house or a coffee shop or something, it'll see that it's not on one of those trusted networks, and it'll try to automatically connect to the VPN. And then the VPN connection info is further down here. So our external host name that should be connected, whether we want split tunnel or forced tunnel, the VPN protocol to use. So in this case, IKE v2, and it's a device tunnel. So we're using certificate for authentication.